Oh my God, 66. It's pretty good. It's a pretty good number. 66th meeting of AWS User Group Krakow. My name is Maciek. I'm with Paweł today. We are organizers, and with our lovely support community builder Maria. We're bringing today a little evening event. I hope you will enjoy it. Today, as usual, we have a partner. It's Philip Morris. So PMI. What I can say about PMI, they are with us countless years, countless meetings, and we're really grateful and for their support, because without them, this meeting will not take place. At least here with pizza and beer, for sure. Nevertheless, we will start with a session from PMI, where they will talk about energy efficient approach. I'm really curious. Now, I'll give you the mic and you will introduce everybody, because he's the new guy.
Okay, so from PMI, we've got Krzysztof. We've got also Razmik. And the third person who didn't join us because she's ill is Karolina, but she's also in our hearts. So big applause for her. And what? The stage.
Thank you very much.
For guys.
Now we'll use this one. Hello, good evening. Welcome to the event. Today we are going to discuss how reinforcement learning can be used for energy efficiency optimization. Briefly about the agenda, we are going to start with a brief introduction. We are going to describe what is the business problem that we are trying to solve, what is our approach, solution, what results did we obtain, and towards the end we will cover some lessons learned from the whole exercise and close with a Q&A session. As said, my name is Krzysztof. Together with me there's Razmik. Karolina is sick. Unfortunately, she couldn't cover her part. We will do our best to fill in her absence. We are a team of data scientists working in Philip Morris International. We are part of IT department, and our goal is to develop advanced analytics data product, which are scalable, robust, and efficient. We cover the end-to-end journey. We start with discussing with our business stakeholders what problems they are facing in their day-to-day activities. We discuss it, we try to understand it, we build a prototype, validate it against available data. Once the value is proven, we are scaling it up, making it robust, and shipping to production. Today we are going to speak about HVAC, so let's decipher this most important acronym in this presentation. It is Heating, Ventilation, and Air Conditioning Unit. It is like a massive air conditioning that you can have at your home, but we keep it at our factories. The goal is to keep temperature and humidity under control at the factory floor. There are two reasons for it. First is, of course, the health and safety regulations with which we have to be compliant. And the second is that if not kept under control, it may negatively impact the quality of our product. As you can imagine, those HVACs are pretty huge, and as with every industrial machine, they consume a lot of energy. Only in PMI, they are behind 7% of our total energy bill, and in the worldwide industry, it is even up to 12%. The 7% of our energy bill is translated into roughly $20 million per year. This number is likely to increase because of constant increase in energy cost. Inflation is everywhere, but also as the number of HVACs is going to increase over time. So we have three business problem dimensions. First is, of course, cost and cash. We want to reduce the energy bill. Second is sustainability. Behind every kilowatt of energy, there is a certain amount of CO2 that is released. We want to minimize our carbon footprint. The third one is that we aspire to be innovative company. We want to have innovation in our blood or in our DNA. So we want to build and deliver a proprietary control system that actually works. Currently, our control system consists of 3 layers: equipment, application, and controlling layer. The measurements of temperature and relative humidity from the equipment layer, so from the factory floor, are transferred to application layer and then to controlling layer, where all the decisions are being taken, whether we should cool down, heat up, or decrease or increase the relative humidity. The orders are transferred down through application layer to our HVACs, and then they are put in live. So every HVAC is equipped with multiple sensors that measure temperature and humidity inside and outside of the factory, and also the supply chain, the supply air temperature and humidity. In the heart of the control system, there's the PID controller, which simply decides if it should increase or decrease the temperature and humidity in the supply air. The HVAC is like a massive mixer of the air, because we tend to recirculate 75% of the air from the factory floor and mix it with 25% of the fresh air from outside. The cooling, heating, reheating, and humidification takes place by opening and closing some valves that are integrated with the system. And in fact, the PID controller is the source of the problem, because we see that frequently oscillations tend to emerge. So in here we have cooling, in here we have heating. And you see that at the beginning it was too hot, so we opened the heating valve. I mean, the PID opened the cooling valve. But then with time, the temperature decreased so much that it had to turn on the heating valve. Then it got too hot. So again, cooling, heating, cooling, heating, cooling. And so the vicious cycle repeats itself. So we know that the PID is source of a problem, and we want to address it. We understand that we must have an additional layer, which is, let's say, logical or intelligent, and that will override the decisions of the PID controller. We envision that the temperature and relative humidity readings will reach the top layer, where the logic and intelligence is applied, and the orders, proper orders this time, are sent back to the HVACs. So the first iteration of the innovative control system was so-called static logic. You can see it as an evolution of the PID controller, on top of which there's a logical layer which encapsulates some logical rules that are coded and respond to current conditions. But the most important functionality of that solution, at that iteration, was that we finally could communicate directly with the control system. So the communication was established. The solution was better than what we had before, but not good yet. It was underperforming with respect to the POC that we ran initially. It didn't consider the long-term dynamics like seasonality, external conditions were ignored, and it was difficult to configure. Meaning that every season we had to fine-tune it for every HVAC in every geographical location. Time-consuming and inefficient. But as said, its most important functionality was the ability to communicate with the control system. And we built on top of it, and we finally started building an intelligent agent, which could not only optimize the HVAC utilization, but is also capable of adjusting to the external conditions, to the seasonality, to local climate, and other changes which we are going to discuss in the future. So,
thank you. So as Krzysztof told, so we were able to control the HVAC remotely using this static logic, and but it was not enough. So it had a lot of parameters to optimize throughout the year, and we wanted to have something that is more intelligent, that can automatically adjust to the conditions that are changing. And this kind of thing exists already in the area of machine learning. It's called reinforcement learning. Yeah. And for the people who are not familiar with the reinforcement learning, it's very similar to the approach where you want to try to train your dog to bring the wooden stick back. So you throw the stick away, and dog does some action. If it does the right action, it brings the stick to you. You give some reward to the dog. Let's say some food or some bone. If it does not, you doesn't give the reward, or even sometimes you may have some action of punishment. So you may do some bad thing for the dog. Yeah, and with the time, dog will learn that if it is doing the right action, if it is bringing the bone back, the stick back, it may get the bone. And how the dog learns that? So at first it will do some random things. It will just run, do some other things. Sometimes will do, and with some exploration and exploitation. So there is this thing between them. It will learn that bringing back the wooden stick is beneficial for it, and it will start doing it. And similar approach is used in the machine learning, in the reinforcement learning, where you have an agent. Agent is the same as dog in this concept, and you have some environment where this agent is playing something, is doing some actions, and via interacting with this environment, agent may learn to do the right things. And environment in the dog analogy is you and your wooden stick. So you give, you send the stick somewhere, and it brings, and so on. So, and so there is an agent, there is an environment, and agent, via interacting with the environment, can learn how to do the right actions. Another analogy that I can bring, or it's very famous for the reinforcement learning, is the game Go, yeah, or chess. So recently there was a couple of years ago that people built the reinforcement learning model that won some championships of the Go or something. So again, they learned with the time to do the right actions on the chessboard or on the Go board, such that in a long range, they are achieving the best reward that is possible. Yeah? And in our case, yeah, when it comes to the HVAC, so HVAC is our agent, and it may do some actions. Yeah, it can do some cooling, can do some heating, and so on, and it may get some reward. And what is the reward? The reward is how much the difference between the temperature, desired temperature, and the temperature that it achieved doing this particular action. So if the temperature set point is 22, it does some cooling, it achieved 19. Then there is a difference, let's say, in 3 points, then you have like bad reward. If your action brings the temperature to 22.1, then the difference is 0.1 degree, then your reward is much higher because it's much closer. But there is also the other part that you want to have also minimal energy consumption. You can also penalize HVAC in order when it is consuming too much energy, for example, this kind of oscillation cases. So these kind of opposite things together help to find the optimal thing, that you are not so far from your set points, and together you are spending less energy. But the problem here that you cannot train your agent physically in the factory. So you cannot put something that is doing in the beginning random actions in the factory, because it may destroy the products, because it may not keep the conditions. In a worst case scenario, it may very humidify, and there might be rain in the factory, or just some water going, or there might be some very hot. So that's why you need to build your own simulation environment. So your own factory, let's say digital factory, where you do some actions, and you see what are the results. So thanks to the historical data that we had collected from different factories, we built a simulation environment where, oops, sorry, where our reinforcement learning agent could do some action, and we could approximate based on this action how the temperature and humidity will change in the factory. And then there is a loop, training loop. So about the simulation environment. So simulation environment, in fact, if we talk in the technical aspects, it's not something like typical multidimensional time series problem. So you have some historical data up to time step t. So you have history, how much, if you remember the graphic that was Krzysztof showing, so you have some part of it in the history and you want to predict what will happen next. So you do these actions, you have the temperature history, you have the humidity history, what will be the next temperature and next humidity. So we trained the model, it's a typical supervised model that you give this information and it says, okay, if you have this, and you do 100% cooling, after 10 seconds, you will have your temperature decreased by 0.3 degrees. And after having this environment, we started training the reinforcement learning agents in this digital simulation environment. So how it is done? It's a typical loop, training loop. So you have some state T. Yeah, at some point you're in the room. You have some conditions. Yeah, and then you pass this PPO is called proximal policy optimization. This is the name of the algorithm that we used as a reinforcement learning agent. And you have some reward that is coming, reward at time t that was coming from the previous action. So you did some actions and you measure, for example, the difference between the current temperature and the set point, and this is your reward. Yeah, the smaller it, the better. Yeah, or with the minus size because reward should be the higher, but it can be the minus of these differences. Then PPO does some action. So this is doing some action. So this is it decides how much to open the cooling valve, heating valve, or humidifier, or the reheating. So then this action is coming to your simulation environment. Your simulation environment estimates what will be your next state if you do this action. So you pass this action to your simulation environment. It says, okay, your next state will be ST plus 1, and your next reward based on your next state will be R. And then this loop continues in a way that we are continuing this loop until we are reaching some convergence. So until we are solving some optimization problem mathematically set, let's say. Yeah. Yeah, and I will pass to Krzysztof, who will explain the rest.
Okie dokie. So we know what we are training and how we are training. Now let's discuss where we are training this. We are, of course, leveraging on AWS Cloud. We have our own computational platform called DS Lite, which we keep under the data ocean. The data are stored in S3 bucket. Every model is trained in SageMaker, which has direct access to the data. Every experiment is stored in MLflow with all its artifacts. The code that we develop internally is stored in Bitbucket. Once we decide that a model is suitable for our needs, we trigger Jenkins job to pack it nicely and to register in JFrog Artifactory, from which it is deployed to industrial cloud where the HVACs are residing. So this is where the integration takes place, and this is where the money is hidden. Of course, the data through Snowflake can be exposed in form of Power BI reports, such that end users can track whatever is happening and if they like what they see or not. As said, we are shipping only the models that suit our needs and meet our basic criteria. So for every model, we are computing a number of metrics. One of them is the entropy loss. With time, it should decrease. We are computing also the average reward, let's say over the past 20 steps. It should be maximized. There is also the proxy for energy consumption, where reinforcement learning is the new solution and the static logic is the previously used one. In here, the larger the difference, the better. There's confusion matrix where we integrate all the actions that a person would perform, and we compare it against the reinforcement learning solution. And in the end, we are manually evaluating the plots if what we see really is solid. So we built those reinforcement learning models first for Romania. But it is one thing to have it in your local environment, in your training gym, and the other one is to deploy it to production. We have to make sure that it really makes sense. And we did it through A/B testing. We selected 30 days, so one month, in which the new solution was somehow competing with the old one. For 15 days, the old solution was applied, and for remaining 15 days, the new solution. The days were selected randomly, such that it is not 15 days in line and then switch to the new solution. We wanted to have the most reliable validation as possible. During the testing, we of course measured the cooling energy, so the energy associated with cooling, heating, reheating, humidifying, and on top of that, how much water did we consume, how much CO2 is associated to what we consumed. And we converted it into electricity cost, steam cost, and water cost. In here we see two tables, one for HVACs 340 and 341, and the other one in the other bay, because HVACs work in so-called areas or bays, where areas should be separated. In every case, what we saw is that the new solution based on reinforcement learning was saving up to 50% of energy with respect to what we had previously. Having such promising results, we decided to apply it to other affiliates, other factories. In Korea, despite the difference in local climate, we saw similar savings in terms of total cost, energy, and CO2 emission decrease. In Czech Republic, still promising, but because of the discrepancies amongst the factories, in Romania, we were dealing with how many HVACs? 8? With 8. In Czech Republic, with 26, which were supposed to cooperate. So slightly different setup, which had an impact on the results. At the bottom, you can see how static logic, so the old solution, operates during one day. You can see those still sharp peaks, and in the next day, you see how reinforcement learning-based solution was used. Striking difference, I would say. So let's move to lessons learned. First, as we represent the data science community, we see that there is a need to have direct and frequent interactions with business stakeholders. They know and they own the process. They know and they own the problems that occur during in those processes. They know what they want to have, and they definitely know what they don't want to have. Without a proper dialogue, frequent interactions, frequent conversations, you will build something that doesn't meet their needs and expectations. And they will not use it, you will not monetize on it. The next three are somehow connected. So a simple solution is better than a non-existing one. Nothing to add here, I believe. If you want to monetize, better have something rather than keep on chasing the rabbit. You can always improve your existing solution, but ask yourself if it is worth. If you already have something running and making some savings, then yeah, please do. But make sure that you're not overdoing it. With reinforcement learning, there's always room for improvement, but business will not wait for it to happen, for you to finalize your desire to build the best reinforcement learning engine in the whole world. So keep remembering what is your goal. Don't waste time and resources. Have a solution, improve it, but keep the development under control. The next two, so every factory is different, and so does every HVAC, and expect unexpected, is more for the scaling and moving from a POC to fully fledged industrialized solution of general availability. Even if someone promises you that, yeah, the factories are identical, the HVACs are identical, they are not. There will be always some differences. There will be always some problems that you will face. There will be missing data or sudden heat gains because of some machinery that is located next to a sensor. And you can't see it on a diagram, but it will affect the performance of your solution. Finally, the MLOps is a must. If you want to go at scale, you have to automatize it. You have to use those MLOps capabilities. Otherwise, you will be buried under countless manual tasks and manual deployment and manual validation. Something that no one wants to do. With that, we welcome any questions from the audience.
Hi, thanks for this presentation. I have a question. Yeah, closer. Okay. Regarding the model and the code, he was talking about a few countries where you tested your solution and deployed into production. The questions are the following. For the different countries, they have different climate, they have different factory designs, and etc. Do you use the same model? Should it be? Actually, it's three questions. Can I?
Yeah. Okay.
They are a batch of questions. Yeah. Is it the same model? Is it the same code for them? And how much efforts from the team required to deploy it to some new location? And yeah, that's it. Thank you.
Okay. So yes, you are right. Not only the climate is different, but also the HVACs are different. So some of them may not do 4 actions, may do 2 actions. So different type of HVACs require different models. So we were retraining, not retraining, but training for the new factories, the new models. Even though it is possible that you may reuse some stuff somewhere, so we tested that some stuff is working also. Some models that we used in one factory may be used in the other factories also. When it comes to the deployment, it's hard to answer because in every case it's different. So if the factory is ready, if you have good IT guys in the factory, it's easier. If you have already existing this static solution, static logic working there in a full scope, then it is easier. If not, then it is requiring some other jobs to be done on the IT, local factory IT, to be able to remotely control these HVACs. I think after a couple of iterations, on the other side, we are not the bottleneck. We can easily get the data, easily run our training pipelines. In 1-2 weeks, have some working models for a given factory. But adding new HVACs might be difficult due to technical things.
If I may add, so assuming that you have identical HVACs, one in Romania and the other one in Korea, you could use the same model in the same setup. Just take it and implant it in the other HVAC. The HVACs should adapt on their own to the slight differences in the local climate. Okay. But what we faced is that there were multiple types of HVACs. Some of them didn't have the rehumidification valves and consisted only of cooling and heating. So it's vastly different if you have only 2 valves and if you have 4 valves. To that setup, the solution could not simply adapt because it would try to do something that it is impossible.
All right.
Cool.
Hi, I have 2 questions. I will start with one of them, I guess. So you started with the data in the S3 bucket already. How do you get the data to the S3 bucket from the HVACs? Because that was not on the diagram. Do you use any AWS services or was it there? I didn't see it. Sorry.
Okay, from
how
HVACs,
the data gets to the S3 buckets?
Yeah, the data are stored in Historian system. And from Historian, we built a pipeline that is transferring data to our landing layer and then is exposed to S3 bucket. Okay. So there is a separate pipeline. Sorry for not covering it.
Yeah, okay. And I guess I will ask this as well. Did you have any, there's always issues with data, but I work a bit in IoT as well. And I'm wondering if maybe you had such issues like maybe the HVAC was measuring temperature and it wasn't sending 20, but maybe the integer value like in thousands or something. Did you do any pre-filtering or any of such data maybe could impact your reinforcement learning as faulty data? Do you have any issues like that?
Yes, so we were filtering the data before putting in the training. So we were together with subject matter experts from that factory. We established for each of the factories some ranges that we think that should be normal conditions. Everything above or below these ranges, we just throw it away. It's not so much, but for example, in shutdowns or sometimes it may happen. And one addition to the last question, yes, we use AWS Athena that is moving data from Historian to S3.
Okay, thank you.
All right, any other questions? Oh, perfect.
I think first and foremost, thanks for sharing the great case and well done. So I quickly Googled. So the global energy consumption for HVACs is 10% of the whole global energy consumption. Yeah. So you say, well, for those factories, you reduce that by 50%, which means that if you would open it up and share with the rest of the world, you could really have an amazing impact on the planet. Have you considered making that open source together with the whole solution?
That's a difficult question. We are building it as a proprietary system. We have to discuss it, especially that we have at the back of our heads the sustainability goals. So that's a fair call, and we have to consider it.
Yeah, so actually that would contribute to your sustainability goals.
Exactly.
Very significantly, yeah. So I think sharing that with your sustainability officer could be a good case, yeah.
Exactly, we'll do it.
Great.
All right, thanks. Perfect. 1 second, it's Slalom.
Thank you. I have a question about simulation itself. What kind of tools did you use to simulate the environment? How did you reproduce it? Was it like some kind of Unreal Engine game stuff, or how?
Yeah, we trained a separate model for simulation. So the idea of this model is you supply the history, like last 10 minutes of your history in what happened in your factory, in your shop floor, and then it predicts the next, the future, and time step +1, and then you continue, you go forward, you use this, and then you predict, and so on. With let's say 2-3 minutes ahead, you are able to predict pretty precisely.
All right. And
so with LSTMs, where you have as an input room temperature, room humidity, supply temperature and supply humidity, plus outdoor temperature and humidity. And with, if you enlarge it with the information on what were the actions taken, so how much did we open the heating valve, cooling valve, and humidification valve, the heating valve, you can predict what will happen as a next step based on the current state of the system and the actions that are taken. LSTMs are pretty good at this. So with that, we have a training environment, which we substitute to the agent. The agent is simulating what actions will be taken. And since these are the actions, it can take the current state and predict, and the simulation environment predicts what will be the response of the system, how much the temperature did decrease, and the humidity.
All right, so I'm guessing the case for a factory that has 26 HVACs would be different to the case when it's only 8. So how many sensors are there that you're tracking information from in different environments? In
the number of HVACs, as we discussed, in Romania there were 8, and in Czech Republic there were 26. But each HVAC is considered, let's say, separately. So each HVAC has its own sensors. Of course, they are.
So the sensor is built into the device, right? It's not in the factory, like in the environment.
Yeah, it is all. It is not that all the sensors are built in, but there are sensors that are, let's say, outside of the HVAC, located at the factory floor, that measure temperature and humidity and share the information with the HVAC unit, because you are mixing the air that is fresh coming from outside, for which we also measure the temperature and humidity, and are clearly outside of the HVAC unit. And we recirculate 70%, 75% of the air from the factory floor. So you have the sensors here and there and inside.
All right, thank you.
Okay, thank you. All right. Second.
I have several questions, if I may. How much time did it take for you to implement this solution since the initial discussion with the business, and what was the team size, just to understand?
A bit over a year, I would say. A year and, I don't know, 14 months, 15 months. Originally, the team consisted of representative from business, so who became a product owner, then 1 or 2 subject matter experts, because it was changing, who knew deeply what HVACs should do, what we are measuring, and how they should and should not act, plus 2 data scientists from our team. Then, as we proved the value behind the idea that we proposed, we had to augment the team with additional data scientists and MLOps practitioners. As we are moving from one factory to another, there are subject matter experts coming from particular factories, and the business representatives are, let's say, coming and going.
Okay, thank you.
So the core team was, I would say, 5 people, with the possibility to be increased.
Thank you. And once you were ready with your solution, with your code trained in a virtual environment and deployed it, is it now evolving on the factories separately on each device, or is it ready as it is and work in initial state?
Maybe I answer, but I didn't get question very well. So the code is the models. So the end result of our thing is some model, which is a kind of a binary file. Or, well, at the end of the day, it's just neural network. This reinforcement learning model is also neural network, so which receives an input and gives an output and actions, and it is deployed somewhere in the. It's called industrial cloud, but it's some AWS machines that are working. They are receiving every 10 seconds the data input and then passing back to the information to the HVAC. So for 3 factories, for Korea, Romania, and Czech Republic, they are working. We are adding more and more HVACs, more and more base, and we are now scaling to other 3 new countries.
So the model is already trained,
yes,
and is not evolving anymore right now.
Okay, if you mean that we are training the reinforcement learning agent in the factory itself, no, we are not doing. We may come back to MLOps, retraining, and so on. We are establishing also this retraining pipeline, and we want to automatize this process as much as possible.
The reason is security. We don't want to have a solution that is running on prod and is evolving without our control and supervision. It may jeopardize the health and safety regulations. It may jeopardize the quality of our product, none of which is acceptable. So the solution that we are deploying is basically a distribution of potential steps that can be taken. So it covers a wide spectrum of possibilities on how and which valves should be open and when. It covers the needs of a specific location. If we see that it is underperforming, or we have an additional idea that will improve the solution, then we will retrain it while keeping it under control. Otherwise, it will be simply too risky.
Okay, I see. And the last question, as I understood, your code is running in the cloud. And is there any potential security issue with network, whatever, because it's not on premises? And how the system will work if, for example, there is no connection to cloud or something like this?
Okay, so the model artifacts are exposed from DataOcean to industrial cloud. As long as the model artifacts are available for industrial cloud, so it is deployed in the industrial cloud, then we are safe and secured. What may happen is that we do not have an active solution in the industrial cloud, and then during the deployment, something wrong happened, and you didn't manage to fully transfer the model artifacts. But we have safety mechanisms to prevent it. So there is no risk that one thing is not available to the other environment.
Right, thank you. Any other questions? All right, thank you very much, guys.
Thank you very much.
Hey, come on, cheer up.
Thank you.
Thank you very much. As always, pleasure to see that. Guys, remember we have a quiz. So there are going to be some giveaways, of course. So go for it. There are some questions you can answer, hopefully right. And then on the end of the meeting, we will give you some giveaways. Do we make a break or we go straight forward? Some small break?
We've got 5 or so minutes.
5 minutes break, right? 5 minutes break, we'll switch the laptops and
AWS stand-up by Wojtek.
Yes. Yes. Let me go back. You just seen all the slides. We can go home. Okay, that's it. I'll be walking a lot, so if you had a Vijay? Okay. Because I'm sweating, so I don't want to raise my hand. Okay, so I'll be moving. I need to know where's the edge, like somewhere around here, right? Further? That's it? Okay, cool. So I'll also use the presenters mode. Just give me a second. It worked. Okay, so we'll kick it off. My slides are not so beautiful as the previous guys, so are going to be boring, but I want you to focus on myself, and maybe we're going to have some discussion. So slides are going to be just a backup. There's not much. There's going to be some slides that are graphical, but the rest of it is just like a title and a few texts, and then we're going to talk. So I'll kick it off. I assume there are no questions, but this is the longest title I came up with. So yeah, but this gives away what the session is going to be about. I'll try to keep it to the topic, but if we have a discussion that deviates, we can go there for a second, but we have to come back. We have like 60 minutes, right? 60?
6 hours.
6 hours.
Yeah, for you.
Okay, so hour per slide. Okay, so let's do it. Now, I have some house rules always. This is how I do it, because this is not like a normal presentation where I show you something and there will be a few diagrams. I really would like to have a discussion with you. So if you have a question, you can shoot it straight away. There's going to be Q&A at the end, but if you really have a burning question, just go for it. And as every presentation goes, if you're students, you ask about my salary. If you're not students, you ask about cost on AWS. But that's going to happen. I know, I'm ready. We'll tackle this question as well. So yeah, discussion over presentation. That's the first house rule. The second house rule is that you're a mixed crowd. I've seen few cool IoT questions. There's not going to be too much IoT. I will try to sprinkle it around. I actually have 2 IoT projects behind me, successful IoT projects. Maybe I should add that. So I know a bit, but it's not going to be IoT related. It's going to be AWS generic presentation, right? So there is a second slide that will answer a few questions about why we're here and what to expect. But yeah, this is the second house rule. So it's not tailored to anything. It's rather like my experience on several projects already, and how to make it easier for you to start with the AWS. And last one is we're not here to certify, and this is something that I have to say. I hope you all understand that we have 60 minutes or 6 hours, depends. And we're not going to learn anything hard or deep dive. I will not go into any specific solution. That's going to be just a 60 minutes plus some Q&A, right? So we're not certifying. We're just going to have a good time, hopefully. And there's beers, there's pizza. So yeah. So that's for house rules. Any questions to house rules? I suppose not. Okay, that makes sense. So why are we here and who am I? So who's speaking to you? We're here to learn how to make it easier for all of you to start with AWS. And there is a certain point where you're either disappointed with what you did, right? You look back and like, shit, I should have done it differently. So hopefully by the end of the presentation, you'll have a better understanding on, okay, what to do in order to find yourself in a month or 3 month time and not regret your decisions that you've made, right? That's the first thing. And the second thing is to maybe encourage you to do it if you're scared to do some stuff, right? Because some people come to us, you'll see who I am in a second, and say, am I supposed to do it? Will cost kill me, etc. Right? These are questions are common. This is okay. I'll try to demystify some of it to give you this courage and give you power to just move on. Now, who's speaking? My name is Wojciech. You already heard that. And I'm from AWS. I'm a CIA, which is Cloud Infrastructure Architect. And I'm basically architecting infrastructures for customers. And this ranges from IoT and goes through automotive. I've been in some game dev. So I've been through most of the industries, and I've seen things. So I hope I'll be able to answer all of your questions, even if they go a little bit beneath the surface, right? Not generalized questions, but maybe something about IoT and stuff. Now, I don't want this to be boring too much for myself. You decide for yourself. So I phrased it a little bit like a D&D campaign. So we're going to do some quests. And at the end, we're going to have a goal that we want to achieve. So in prologue is like who you are in this whole presentations. Because I believe that you may represent different aspects. You may be a single developer who just has an AWS account and wants to do some magic, maybe break the chasm, right? And move on. Or maybe you represent a huge enterprise. That might also be you. And I will try to address all of these personas, starting from a single developer who has a PC and just credit card, and huge enterprise that wants to do the same but on a higher scale, right? So the main characters for our quest today, it's what I just said. There's going to be an individual builder. This is how I'll call you. There's going to be some middle ground, which is a small business, usually very local. It's not multi-regional. That's going to be there's something like in Poland or maybe in Europe. That's for you to decide. And there's like large enterprises. So this is usually the companies or maybe gathering of people that span throughout multiple regions. And that's going to be a little bit different story than when you're individual builder, right? There are different decisions to be made, or maybe the same questions are being asked, but the answer is different. So we'll try to make it work for everyone, right? At the same time, making it not work for anyone. You cannot please everyone, but I'll try. Now, the starting point is, as you can see, credit card is active. You can go, set up your account, put the details, and you're ready to go, right? This is what you have to do in order to start in AWS. And I bet you all know that. You have some experience. So this is the starting point. We'll skip some, and I'll show you what we'll skip, and we'll get to the experience bit in a second. Now, the main goal is to tame the scary dragon, and I'll show you the scary dragon in a moment. So let's meet the scary dragon, right? That's it. That's the scary dragon. And if you look at it, it's like really scary. There are bits that I'm even scared to look at, like patch management. If I can, I just don't do it. I give it to someone else. There is so many things that I myself wouldn't do if I was an individual builder, that this is actually scary, right? But if you want to be successful to some extent, especially when you're a large enterprise or maybe you're like a business, you have to have all of it to some point. You cannot skip stuff, right? My favorite topic, and this is the closest to me, it's networking connectivity. And you have to have that. You have to connect to the AWS. And within the AWS, you also have to connect between workloads and between services. So there are different things that you have to account for, right? Now, we will not go through this whatsoever. I will skip 90% of it because, and there is a good reason for that, there is already documentation for it, and you can read it. There is a perspective guidance. So if you Google or DuckDuckGo maybe, AWS perspective guidance, I know, multi-account structure, you'll get at least 4 blog posts or documents on how to do it, right? They are kind of in-depth, so you don't have to read all of it, but you read it, you gloss over it, and you more or less get an understanding of how to do any of it, right? So what I'll focus on is rather going through all of the points, I will tell you what I've seen on several projects that backfired at the customer, right? While building this, and which is maybe common to every single deployment, right? So you're building yourself a landing zone or maybe AWS environment, and I bet my money that the things that I will speak about in a second, if you don't think about them beforehand, they'll bite you in the ass. Honestly. This is like maybe some hazard piece, but I'll bet my money on that. So first, let's go to the glossary, because I don't want you to mix stuff. If you're already familiar with all of this, congrats. But in my job, whenever I meet a customer for the first time, they mix it all together. They interchangeably use different terms, and it's hard to discuss anything, right? Wait, here?
No, the AWS Landing Zone was a service before, so it's a mix-up now.
Yeah, so Landing Zone and AWS Landing Zone, that's it, right? And then you get a control tower, and people are like, what the hell's happening, right? So I want to go briefly, really briefly. You can read it for yourself, but you don't have to. This is maybe more useful, right? So multi-account environment is like the big thing that you're building, because I recommend building multi-account environments. Like, don't go for a single account that does everything. Multi-account is the way to go. Now, within multi-account environment, there's going to be a landing zone. And landing zone does not span throughout the whole multi-account environment. It's just a piece of it. So what Landing Zone does is the starting point. So you come to the environment and you want to start somewhere. So for example, if you're an IoT, you may have a data ingestion platform that just accepts data and sends it further, right? Or maybe does some formatting for it. So you're going to have a separate team. And in order to make sure that this team can start off real quick without too much hassle, you have a landing zone. So for example, you have a vending machine, so-called mechanism that we call it vending machine. So as a customer of your own company, right, you come in, you see the products and say, oh, we're this. And then you click a button and suddenly you have the whole sub-environment being set up for you, right? So this is what landing zone is. It just gets you really quickly, going really quickly. Now, AWS Landing Zone is exactly this, but for AWS. Because Landing Zone is also for other cloud vendors. It's not AWS specific. AWS Landing Zone is AWS specific, and it grabs a lot of concepts, or maybe all of the concepts from a well-architected framework. I don't know if you heard of that, but if not, just go to DuckDuckGo, Google it, and you'll see what architected framework is. It's a huge framework. We'll not get into this. It's quite nice, but it's a lengthy process to go through it, right? So not for today. Now, inside of the AWS Landing Zone, you can do it different ways. You can have a custom one, so build everything in Terraform and try to manage it and organize it for everyone else. Or maybe use something that's already managed for you, which is, for example, AWS Control Tower. So AWS Control Tower is a solution to deploy AWS Landing Zone, which is a part of your multi-account environment, right? This makes sense? I want someone to say like, and represent the whole group. Okay, thank you. This is usually the case. Someone says yes, and we move on. Yeah, that's it. That's the glossary. Everything, yeah, there's the question. Let me tell you, Landing Zone is a starting point from which your organization can quickly launch and deploy workloads and applications. So Landing Zone is a concept. It's nothing tangible. Do I get smarter now?
No, you get louder.
This is a trip hazard. I tell you, I mean.
Now jump around it.
Okay.
Okay, sorry, but I need to have this one to give to the
no,
people
that's
if
fine,
they
that's
have
fine.
questions. Okay, so
we have
don't
a backup.
hesitate.
If I trip and die, then there is
no problem,
another guy who can continue. Okay, so basically, Landing Zone is a concept. It's nothing more than just a concept. So imagine that. So what happened in networking connectivity, wide range networking connectivity? That might be like an analogy to that. Certain vendors started to deploy their own SD-WAN technologies, so everyone wanted to be first in the game. But then IEEE came in and said, guys, let's standardize it because you're getting too crazy. Everyone's doing something else, let's standardize it. So they come up with an SD-WAN like overall concept, and then now everyone is standardized. The same happened to Landing Zone, right? It wasn't too official, but for example, but we have multiple cloud vendors, and every cloud vendor was like, do it this way. No, do it this way. So someone came in and said, no, wait. Let's say that there is a good way, generic way of how to build a good starting point for everyone, regardless of the cloud vendor. So this is an effort to make sure that wherever you go, there is a best practice. Now, it might differ in details, so AWS is going to do it differently than Azure, but Landing Zone is just a good start for cloud. I would say that. Does it make sense? I hope. If you want to argue, then let's go. Okay. Any other questions to the glossary before we move on? No. Okay, perfect. I'll put this down. So there is a Chłopski-Rozum strategy, which I really like and recommend. Before you do anything, always think about does it make sense? I know my business pushing, but does it really make sense to do it? And then when you accustom this strategy, then you can speak back and maybe have a good reason for that before you start doing anything. So I like the someone phrases. Someone means not everyone. This is equally someone means not everyone, but always remember that whatever you do, someone has to, these three things, right? Someone has to implement it, someone has to operate it, and at the end, someone has to understand it, right? I met people who are doing projects, amazing projects, but when they try to explain it to anyone else, it was only them who understand it end to end. They had to pick a team of people who together understood it, but no other person than this architect understood the whole concept, right? He couldn't even explain that. So what I recommend is whenever you start building something, think about this, like, can I understand it and can anyone else understand it? That's a first rule of thumb. So one rule is really important. And the other thing is that, and this is pretty common, if you have a requirement, just meet it. Honestly, just meet it, don't excel at it. Because excelling can put you in trouble, takes more time. And what the folks from the previous presentation said, like, is it worth doing, right? So you have an efficiency, you can get this % more, but like at what cost? So it's the same rule here, like lessons learned from the previous presentation. If you have a requirement, just meet it. That's going to be fine. We call it good enough is enough. Any questions to that? Chłopski rozum? Okay. It speaks to everyone. So we start with the main campaign, right? So we know who the characters are. We know what we are about to do. Now, the main campaign is going to be based on my experience. So you may say I don't represent AWS per such. It's like my experience with the customers. I've been through several projects ranging from small business to really huge enterprises in like 9 regions, right? So this is a huge deployment. I also worked with an individual builder, which is myself. I have my AWS account, and I redid it from scratch 4 times, right? So I have this experience of looking back and saying, oh, this is crap. I have to scratch it and start it from start again. This is a very typical problem for programmers, right? The coders. They look back at their code from a week before, and they're like, oh, that's an awful code. I need to rewrite it. The same happens for AWS. You look at your infrastructure, you look at your solution, you see a lot of garbage, and you don't really want to move onwards because you know it's not going to scale or something like that. So quest number 0 is do the obvious. We'll not dread over it too much. Just read your documentation, know what you're doing. Don't get into the solutions that you don't really understand, but someone pitched it to you as a marketing pitch saying this is the best solution ever, and you're like, okay, I have to try it. Especially with AI nowadays, it's like, I have to have AI. AI makes sense in certain places, but in certain it doesn't. Just have some procedural algorithm that generates something or calculates on analysis, that's fine, right? There is a place and reason for everything. So if you have some experts around, don't be scared, ask them, right? If that's public forum or your colleague, that's also fine. But also, what I would say is, certify from time to time before you start doing anything. But that's quest 0, so I'll move on. This is out of scope. I don't even accept questions on that. So let's start with quest number 1. And this is something that's tame. Like you look at this and it's like, okay, this is boring, account structure, everyone knows that. But this is actually the most important bit here. Like this one is the most important bit. So account structure usually comes in a shape of what do we need now, right? So we look at our organization, or maybe you look at yourself in the mirror and it's like, what do I need? Okay, I'm an admin, so what we usually see is root user, then admin, and some people go the extra mile and create power user. That's it, like these three are the most common. So you get root by default, and then you also kind of get admin by default, but power user is an extra step. Don't do this. Stay a day on this, sleep over with this idea, and create some other accounts. And I'm not asking you to go too deep, like creating multiple roles, but just like make sure that you know what's going to be required for end product, right? Foresee what you're trying to build, what personas do I need to have, write it down, create it. So I can give you an example because I believe that that's going to strengthen the message a little bit. So how this can backfire at you. So I've been with a customer who deleted admin. They were too scared, so root has to be there, right? You have to have root because billing and stuff. Now you don't have to have an admin user. You just don't. So they said, our security is so strict that admin is too much. List privilege, right? You know list privilege. And they say there is no one who should have that power. So we shall delete the role. Like there's no admin in our infrastructure, right? So what they've missed is that in 3 months from when they made the decision, they actually create a role in real life that would require the admin privileges. But they couldn't do it because their guardrails, security guardrails, which forbid them to create stuff, they couldn't create admin again. They just blocked themselves out of creating an admin. And then when it came to accessing, root can do it, right? The root can go in and override everything because that's root. What they forgot about is that the person who can access root is on vacation, right? Typical stuff. He cannot actually come to the office. He's not picking up the phone, so it's like a month delay because he was forced to go on a leave. He had 90 days left of his vacation, and they forced him to go for a month vacation. So this is more of a funny story, but the thing is that you have to come up with your structure, think it through, give it to someone else, and say, like, does it make sense? Yes, implement that. And my call for action here is that don't neglect it. That's it. Account structure is important. You don't have to go deep with that. Just think about it, what you need, create it on the first day, and then use it further on, right? Now, the last, on the quest one, the last point is calculate operational excellence into least privilege. Like, what does it mean? So operational excellence is when someone can do whatever they have to do efficiently, right? So I can give an example of a networking guy who's also a security guy. There are personas like this. So imagine that you're a networking guy and someone tells you, can you change this route table, for example? You log in, there is an SSO landing page, you go in, you log in, you change something, but then to log out, if you want to do something in security, you have to log out and log in again to a different role, right? So you log out, log in, and then you have to do everything, something else in networking. So you have to log out and log in. And then if you want to do something else, you have to log out and log in, right? This is not operational excellence. This is pain in the ass. Someone just created roles that do not fit your real life. So this is not even least privilege. This is not enough privilege, right? So think about this. Your least privilege is not purely business driven. It's sometimes real life driven. So you have to recognize who are the people working with your project, or forthcoming people that will work with your project, and calculate that into your least privilege, right? Create the roles that make sense and do not stop people from doing stuff. That's quite important. Now, questions on quest one, account structure, before we move on to others. Yeah.
Wait a moment.
Yeah, I have a question about your AWS CIA powers, or basically anybody in AWS. Is there possibility to create an admin account for some account, like remotely? Is there somebody who could do that from AWS?
No,
okay.
No way. No, there is no way. So it doesn't work this way. Like, we don't have an access to your account whatsoever. No one has except the root.
Okay.
So if you lose access to root, honestly, no one can help you. There is no one in the whole AWS, in the whole Amazon, not even Jeff, who can go in and log in and open an account. That's it. You lost it, right? I hope that answers your question. But let's talk after this session. Any other questions to quest one? Account structure? No. Perfect. Okay. So identity management. Who knows what that is? That's the most boring stuff of every project, right? Oh, okay. We're going to have a very interesting discussion. Someone said that this is most interesting. This is the most skipped bit in every single project I've been to. Everyone just stepped over it. There is identity management, and they just do this, right? No one wants to do it, especially when it already exists somewhere else. And that's usually Azure AD. That's 90% of the time. This is Microsoft Active Directory, which is somewhere. And then you ask questions like, where is it? And they're like, it's there, it speaks to us, but we don't know. The guy who did it left, so, but it works, right? So identity management, and the first thing that, like, I'm talking about define as is, right? So if I come to you and you're my customer, so we work together, I work as your solution architect, I ask you like, okay, so how do you do it now? And people are like, we don't know. I log in, I have a landing page, so it works, right? No one knows how it works, and we cannot help you if you don't help us first, right? So it is impossible to integrate your identity management if you want to have it end to end. We can split that, and you can have your identity management that works already here, but then you're going to have a separate one, right? So my ask is, whatever you do somewhere else, like outside the AWS, try to document it, right? And when you go to the AWS, also document how it works, because as is really painful. Now, to be is how do you want to integrate, of course, and this is also really neglected. Like everyone hates to do this because this is a hurdle that you have to go over in order to do fancy stuff. Like sexy stuff is beyond that. You have to do it first, and then you can do the cool stuff, right? But no one does it, and no one works from real life. So the customer I'm working with right now, when I ask them, okay, so what are the roles you want to have? Like, who's going to work there? And they told me DevOps. Makes sense, right? Infra security. There is cloud security and on-prem security, but this guy also wants to have an access to cloud, so security. And you have plenty more. So I asked them, like, how did you define it? Can you show me the documentation, maybe explanation behind it? And they told me they found it on the internet, right? These are the typical roles, so we want this. And I'm like, guys, this is not how it works. You have to look at your team and say, you're the DevOps, you're this guy, and then I'll create the roles for you. And this is not only based on human beings. Some human can be two roles at the same time, so we call them personas. Look at someone and say, ask yourself a question, like, who are you? You're a DevOps and networking guy at the same time. You work like Batman in a day, in the night. So this person needs two roles. So work backwards from real life. And this is an honest advice. Don't look at business. Okay, that may be the better advice, but business doesn't know who's going to operate that. They have this very generalistic Platonian way of looking at tech. It's like DevOps. No, maybe you don't have a DevOps. Really, there are companies that don't have DevOps. They have something else, but which combines DevOps with, I don't know, some other ops. So create an account for this person, right? Don't worry, business will understand. You just have to explain that. And then solidify the identity origin. This goes back to like, what's this? What do you want to be? Just sync it together and make sure that it's one-to-one, right? Nothing more than that. So two questions, anyone? Two boring stuff? The third one is not that boring, but these two are something that you have to do. Okay, question number 3, access patterns. Who knows what this is without reading? This is not boring. This is this is cool stuff. So who knows what access patterns is? So far, with all the customers I had, no one knew what that is. When I asked them, can you define access patterns to me? Or do you have any documentation on access patterns that you foresee will be used in your project? No one, like 0 customers had that. And access patterns is very simple. Who is going to use your application and how? That's it. Tell me, right? And this ranges from people to machines to sensors to other applications calling your application. I need to know that. Why do I need to know that? Because I'm preparing an infrastructure for you. So if you don't tell me now, I might not be ready to support an access pattern, right? I can give you an example of a customer who didn't tell me about single access pattern that moved us back like a month. So I was doing multi-regional infrastructure for the customer. I prepared for everything. That was actually the IoT project. So they had a lot of sites that went through the VPN, and there was an IoT hub which did the inspection and maybe some preliminary filtering for data, and then send it to Sitewise and IoT Core and all of the fancy stuff. Snowflake was there, only the cool stuff, right? And I asked them, like, what are the access patterns? They didn't know, so we worked through this. We spent like 2-3 hours defining who's going to use it. They told me about all of the sensors, all of the Raspberry Pis that they had very professionally on the side. And we did all of it for him. We started already doing some Terraforms because they use Terraform, started to deploying that, and someone jumped in and say, Wojciech, listen, We also need people to have access from internet, SSH into EC2s. And I'm like, okay, like how? It's not in infrastructure. I cannot let anyone in because I didn't prepare for that. We have to go to the drawing board, day 0, and I have to incorporate external access into your VPC, right? Because they didn't know it's going to be there, but they talked to the CEO, and CEO said that would be cool because we didn't have it, but we're in the cloud. So I promised, because we had all hands, and I told them that it's an innovation coming. So now you will be able to work from beaches and forests and stuff. So we need that, right? It came from business, of course. But they didn't tell me, they didn't foresee it. So we had to move back, redraw the whole 9 regions infrastructure and do it again, right? Because security was messed up from now on because we mixed public traffic with private traffic. So we have to separate that. And all of the cascading problems started to appear. So it wasn't a simple fix. It was just, back to 0. So think about access patterns and also think about forthcoming access patterns, right? So this was an example of a forthcoming access pattern. They just didn't predict that there's going to be a change, and change happened and screwed the whole project. And we moved back a month, right? And then when you design your infrastructure, there is no common agreement on where to start. My go-to is access patterns. I try to design my infrastructure based on who, where, will be using the platform I'm building or the system or whatever. Even if you're an individual builder and you have single VPC and maybe 2-3 accounts because you don't want to, mess up with a fully fledged multi-account environment, think of what you're going to do with it. How would you like to access? Will it be just you accessing from home, or maybe you're going to have some Raspberry Pi that's going to constantly push some data up, right? This is different access pattern. You have to account for that. Maybe that's a different type of infrastructure. So make sure that you understand your access pattern first and then start designing your infrastructure. Does it make sense? Yes, right? I hope so. Now there's going to be something boring next, right? Questions? No. Okay, is it about cost?
I have a question. Yeah, no, it's not about cost and your salary. I know that you're disappointed, but my question is, the access patterns can have always also the name like customer journey, because you have different customers to the applications. Can be machine, can be a device, human, external user, and how at least we're calling it a customer journey, and we define those personas or persona journey. You mean it's something like this, right?
So I think that what you're referring to is a broader term, and access pattern is a part of it. So customer journey might be, there is a developer who's going to write pipelines for some IoT platform, right? So his journey among access patterns is more than this. So he has to get an account. He has to get all of the
scope of this
yes.
particular.
So exactly
deployment.
Within this persona,
yeah.
they'll be accessing platform somehow, and you have to define that, right?
All right.
So yeah, one person might do it different ways.
Yeah,
so
of course.
There might be corporate access, remote access, and if such, then tell me, because infrastructure has to support that. But that's exactly, customer journey is a cool name for like a broader scope of.
All right.
Yeah. Good question. You might win a prize, by the way, by asking such questions.
So I've got a second question.
Yes.
As organizers' questions. So currently, for example, to EC2, to access EC2, you've got like 4 ways, I think. Is there any one of them mostly recommended by AWS?
Yes, the most secure one.
Great. So which is?
Again, there is one answer to everything, right? No, 2 answers.
Depends.
42 and it depends. Yes, you pick one. So this always depends. And remember that none of the accesses is magical. Like all of them rely on a low-level networking. So even the new access that seems to be accessing your private workloads through internet in magic ways, you don't even have to have a public IP, but you can SSH in. It's actually not, right? So it does nothing. You have public endpoints. You still go through the public internet to public endpoints, but the IP is masked. That's it, right? So you have to understand what you're doing, and I don't have any recommendations. But if I were to pick one, SSM is the best one. Because it's built in, it's kind of managed, right? Because you don't have to worry about a lot of stuff. And it's secure, and you can build it into your access management, which was Quest 2, I think, right? Identity management. So you can know what's... So SSM, is that the right answer? Did you expect that SSM or wanted Bastion host with SSH?
No, like, I know that there are a few ways, but was interested what you are thinking. Which one of these things depends. You recommend or you like?
It heavily depends. But if I can incorporate SSM into my infra access, I'll usually go for it. Yeah.
Okay, that's good enough.
Cool.
Anybody else?
Yeah. Okay. I think we can move on. There's going to be Q&A at the end, so we can also talk. So there is network, which is something I like, which is boring, right? Boring. This is messy because people don't know how to do it. They come with a preconceived notion about, okay, we know how to do it on-prem, so we know how to do it in cloud. That's a mistake, but we talked about this on the previous talk. So is there a recording? Yeah, so you can watch that, right? How to mess up your network in AWS. Nevertheless, don't worry about your network, because the second point says network is easily expandable, and that's true. So you can start very simple and then add on top of that. But there is one prerequisite: you need to know your access patterns, right? So if you don't support your access patterns from the scratch, from the very beginning, you might have a bad time, because you might actually not be able to extend it to the way that you need. So don't worry about that. And second thing is, sometimes it's not needed, right? Sometimes you hear about, who knows what Cloud One is? Someone has to. No one? Okay. So Cloud One is a multi-regional solution that allows you to establish a backbone for your whole infrastructure within AWS backbone, right? So this is what Cloud One is. And when you go to the marketing side of Cloud One, they will not tell you it's not for individual builders, right? Because if you use it, that's a benefit for me and for other AWS folks. Like, so use it, use Cloud One, but you don't need that, right? Think about what's needed, build the minimum viable version, and then build on top of that. And if you look at networking, this is usually the biggest cost for every infrastructure, comparing it to the effectiveness of what it does. This is pure cost. It doesn't bring you anything. You have to have it because you have to access your compute, right? So think about this. If you, the more you build, the more you pay for something that doesn't bring you value. So do the minimum needed and then expand on top of this. If you think that there is a solution that's cool, think if that's for you. If it's not, don't use it. And this comes from AWS consultant. Like, just don't use it. Use the simplest way that works for you and supports the access patterns that you have. That's it. This is what I would say about networking. Any questions to networking? But that was the quick one. Yeah.
So my experience is that actually sometimes it may be better from the beginning to prepare for multi-region, for example, from the code perspective, because I found it's very difficult actually later to add into code, Terraform code, whatever, to add multi-region capabilities.
Oh, yeah, definitely. But this comes back to access patterns. So access pattern might be that your workloads must be accessible from multi-region. Not today, but in a month. This is your access pattern. So you have to build it. You have to build it into your infra from the scratch. So you're right. Sometimes you have to build multi-region before you even go multi-region, because some access pattern are waiting to be leveraged, but not today, but in a month. So we usually call it future-proofing your infrastructure, right? So you have to think about, okay, today it's small and we're going to test and dev test and stuff. But in a month, there's going to be different sites joining and they're going to be in different regions. So yes, you have to account for that. And that's a good point, yeah. And then you pay money because it's there, right? You're not using it, but you will. So you have to pay for infrastructure. Any other questions to networking? Yeah, there's a question. Wow, networking so far. Two questions.
Networking. That's the most interesting topic, or least interesting topic until it's the most interesting topic when something breaks, right? So I guess you said that maybe you shouldn't focus on it too much, and if it works, if it's enough, then it's enough. But
okay, yeah,
it's good enough until it breaks, right?
Then,
and if you allow you are speaking about landing, so if you allow your workloads, okay, every account can create public subnets. Then if something breaks, maybe you don't have this like central hub account where you can put some firewalls or anything. So maybe
yes,
where
so
do you put the limit?
There is one topic that I'll be really cautious about, which is usually direct connect. So direct connect is easy until it's not. So if you use VPNs or you use public access with all of the level 7 security with WAFs and DDoS protection, that's very extendable. Like you can public subnet is something that you can delete like this, right? You can create it like this in a second. So this is fine.
I was not really talking about direct connect. I don't know if you got that from me, but more so if maybe about accounts where you put your applications in. Would you allow those accounts to have public subnets? Is that good?
Okay.
Or is that not good? Or you should have a hub networking account?
You hit the spot. Accounts have nothing to do with infrastructure, like nothing, right? So this is a common misconception this is my pledge to fight this, but it's not your fault. This is the documentation that the AWS has. There is a lot of work to be done on that, but accounts have nothing to do with infrastructure. So you may have a lot of things in an account, even networking, but some other accounts using that, right? So it's still extendable. This is there is an action called resource sharing. So account-wise, you're still extendable. Like if I have a firewall, I can even give it to you because there is an account organization sharing, so you can use my account, right? And my firewall, my transit gateway, my stuff. So whenever something can be added or subtracted, I will still not worry about this. It might be a hassle, it might be a problem to delete it or add something, but it's not that big, right? It doesn't move you back to the point one, to step one, that you have to think about completely new infrastructure. You have to redesign it. So I'm not saying that everything's going to be like this. Some things will move you back a week or the day. But when it comes to let's say direct connect, I would watch about that because direct connect is tied to geography. It's a physical thing. And it's very complicated because there is a limited BGP enabled on it. This is not even the full BGP. This is like a crippled BGP that doesn't support all of the features. And people trip over that very often because they think they can enable that and that's going to dynamically scale. No, right? This might move you back quite a lot. And the example I gave about remote access was actually including direct connect. They didn't include that, right? But everything else is pretty much okay to forget about in the first day. And add it later. If you have an example, we can talk about this, but I think that...
Later.
Yeah, later. Any other questions about direct connect? Cool, no questions. Okay, so this is the last question, and it's 42 minutes. There's a question.
A question from Karolina from our YouTube.
Is that Karolina from last session as well? I think that's Karolina.
I know, but maybe this one. No,
okay,
but don't know. Karolina asking this: do you prefer creating shared networks using Resource Access Manager managed by the team responsible for Landing Zone, or do you leave this to the workload teams?
No, always infra team. That's my go-to. I don't know where. You're there. So, Karolina, if I might suggest one thing, if there is an infra team in your in your org, let them do infra. Let workloads do workloads, and that's a good division. This is a good rule of thumb. If there is a developer who wants to write code, let them write code. This is the whole notion behind DevOps, right? We know why DevOps exists because DevOps traditionally was done by coders. Right? They had to do all of that stuff. And someone say, we pay you so much money for coding, let someone else do the thing that you're not fluent in. So DevOps, right? The same goes with networking. Like if you have someone who's good at creating platforms or someone good at creating something of business value, let networking people do networking. So my answer to Karolina would be, if you can, scope this, in terms of business reason and give it to the right unit, which to me is infra is done by infra team. Within infra team, you may have networking and other stuff. Maybe the whole infra is being done by infra team, but yeah, give them the right job to do. I hope that answers the question. I don't know if Karolina is there, but Karolina, I hope that answers the question.
Previously was Julia.
Julia. Okay, the previous question. Okay. So now we have a last quest before we slay the dragon or tame the dragon. It's actually about deployment sources, and this is crazy funny when it doesn't go wrong. It doesn't go right. So avoid drifting at all costs. Like, what's drifting? Like, if you don't know what drifting is, drifting is basically two different agents do or influence an object from different points without syncing, right? So the good example is I do my terraforms and everyone does terraforms, but there is a lazy admin who just wants to add a single route, right? It's like I just want a single route. So I log in, I open the route table, and I add the route with my mouse and my keyboard. This is a drift because Terraform doesn't know about this. And this might actually screw the whole project up. Honestly speaking, because troubleshooting drifts is crazy hard. Because Terraform, let's stick to Terraform. Like, there's a cloud formation, but it's the same concept, right? They have no tools to recognize the drift. They just believe that what's there, it's up there as well, right? So you tell them something, they develop it, or maybe they delete one thing and recreate that from the scratch, but that's really happening. So drifts is something that you want to avoid. And this is, I encountered drifts on almost every project. There is one project that I'm currently at, which has so good operational culture that they are scared of drifts. But you can hear that whenever you join the meeting, people are like, we are scared of drifts because we had that before and we lost a lot of money on that, right? So avoid drifts. If you're using Terraform, use Terraform. If this is hard for you to add one thing because you could do it through console in 5 minutes, hard life, right? Go to your Terraform and do it through there, right? So now, garbage collection. Do you think AWS has that garbage collection? Do you know what garbage collection is? Right? Yeah. So garbage collection in programming, there are programming languages, the operating systems that can collect garbage. So for example, if the process dies, you as a human, you don't monitor that, but your operating system may look at this and say, oh, this is useless. So I just throw it away. I release some memory. So we collect garbage and throw it away. In AWS, no garbage collection exists. This is a notion that died long time ago. Now it has been put into smaller pieces. We have, for example, memory release or something like that, but there is no garbage collection collectively for new products anymore. AWS doesn't have that. So what this might cause is that the more you grow, the more garbage you may have laying down in your infrastructure. And when you go into the console, you're just a human being. So you look at your 100 EC2s that are running, and you have no freaking idea which one does what, because naming is messed up. You didn't come up with a naming convention. You just don't know which one's garbage, which one's useful, right? So think about garbage collection strategy. What might help you is, for example, naming convention, right? So you may name your devices in a way that you can immediately recognize that certain projects has been decommissioned. So why there is an EC2 that has this tag in it, right? Or the name of it. So you delete that. There are other mechanisms to do so, but my only advice is that think about this in advance. Before you start creating resources, what's your garbage collection strategy? The worst you can come up with, which I use, is going to add like name to be deleted, right? So then I can look it up and say, oh, 300 resources to be deleted. So I'll just delete them one by one. But that's a strategy. It's really bad, but it's a strategy. So come up with your own, but have it. Maybe you know you'll never use it, but if their time comes, you have it. Now, KISS is, of course, keep it simple, stupid. This is like a famous abbreviation in IT. And this just speaks for, if you're deploying something, just make it simple. Don't over-engineer it. And this also ties back to good enough is enough, right? Just create just meet your requirements, create whatever you need, not more, you're going to be fine. That's just one last thing. So do you have questions to deployment sources?
So maybe a comment about drifting. So I fully agree about drifts, but maybe there is something coming. Yesterday, actually, I listened to a podcast about the system initiative. So this is the guy, Adam Jacob. He was, I think, he was one of the inventors of Chef a long time ago. And probably the system initiative tool, which is very alpha, this is about actually going both ways. When you do some things on the console, it will reflect in code. So this is the second wave of DevOps. So this is something.
Yes, but if you look at this closer, and if you compare it to medicine, this is treating the symptoms, not the origin, right? So it's cool. I think that's needed. So if we could have a tool that will actually look at drifts and inform you about that, and there are tools like this even in AWS that may do it, I would also speak to the origin saying like, don't do it in the first place, but if you do have something that's going to fix it for you, right, on a low cost, because there's always cost assigned to it. But I agree that would be cool to have such a thing. But then will this be, an overarching solution that will help with every drifts, or that's going to be dedicated, for example, for certain solution that you have to use, right? So
I think we will see. This is the second wave of DevOps. I recommend to read about it. So this is definitely not about the drift itself. It's about the culture change.
Yeah, that makes sense. That's a culture change. Yeah, I fully agree with that. Okay, so I'll move on, and then there's the epilogue. So what we did, it's not like we didn't slay the dragon, right? But we tamed it a little bit. So whenever you look at this, before you get into creating stuff in any project, which deals with not only AWS, but any, well, okay. There's a drawing lesson after that. So yeah, coming back to the point. So you still have to do it if you want to be successful. Not everything, but most of it. You have to figure out how to finance your project and how to then calculate costs for different users, etc., right? But if before you jump in and try to slay the dragon, you may as well go through the quest first and try to think about like access patterns, identity management. And I know that some of them sound boring because they don't bring immediate value. These are not the things that you signed up for. You just wanted to jump in and start developing. I fully agree. Like this is what I do when I do something in AWS. I just want to jump in and deliver value. But first, take your time to figure out the 5 things that I showed you. And from my experience, I can tell you that if you don't, you may be okay. But if something's fired back at you, this might be really severe, right? So it either might move you back to the starting point, or maybe you may pay a severe cost in expenses, right? Because you didn't foresee something, or maybe there is a garbage EC2 that generates cost, and this is the only way to recognize that is the end of the month when the bill comes and you see that there is an EC2 that you didn't turn down. And now we have thank you and also Q&A, but also have the QR codes. I don't know if you want to show them now or.
Yeah, you can do it.
But which one?
And we let's leave this one. Any questions? I have enough long cable.
Thank you. Thank you for our presentation. I have a question maybe related to garbage collection and the overall management of infrastructure. When I first came to a project where infrastructure was on the AWS and I opened the console, it blew my mind. And then when I took a look at the terraformed code, everything became pretty simple. Mm-hmm. So my question is, if it's really possible to manage AWS effectively just through the console without keep it in, for example, in Terraform, where you can see everything you have documented, well structured, etc.
Yeah. So what I would say about that is that console of any sort, not only AWS, was never built for observability and ease of reading, right? So the same, for example, if you go to Linux terminal and you have a huge output, you may complain about like this output does not fit into my screen, so I have to scroll down, scroll up, and there is no Control F function, right? Back in the times, you couldn't even look through it with find function. So if your infrastructure is big enough, I wouldn't blame console for that, because console has to be restricted on the screen, right? And this is the maximum we can do, not only AWS, but Google and Microsoft as well. So I wouldn't recommend using console for...
I meant the interface in the web.
Yeah, that's console.
Oh,
yeah,
okay.
that's console. But it's the same. Like if you have a white text on a black background, it's not that far away from the web. It's HTML that's being displayed for you through CSS and stuff, right? So it's exactly the same. It has a confined space that you cannot define for yourself because it's not flexible. It has been tailored for generic audience, right? So that's why we have different tools. So I can give you an example. If your infrastructure consists of thousands of EC2s, like thousands of EC2s, there is a dedicated solution that's going to, combine them into tables, and you see groups of them. And then comparing that to the AWS console, this is, 100 times better, because you can see everything as if it was actually made for this type of solution, which it was, right? So then you have an IoT platform, which has one EC2 and a lot of managed services. And suddenly we have a tool for you that you can look at it and have a nice dashboard, because you can put it in Grafana, which is also a managed service. There is a managed service in AWS. And suddenly you can actually use console to look up everything that you want, even infrastructure-wise. So again, depends, but I wouldn't use AWS console for management, like honestly speaking. I would look for something else depending on the use case that I have, either something open source or create something on your own. For monitoring, it works because monitoring, like you have two types of monitoring, right? There is an overall monitoring that you just like CMS style, when you have a huge screen and there is diodes and graphs, and you have a pinpoint monitoring when you just want to look at certain thing and look up CPU or memory usage of that stuff. So for this monitoring, yes, you go in, you move into your EC2, you look at this, say, okay, I can monitor it with my eyes. But when you want to monitor the whole solution, console is not, again, it's not a thing. There is tooling for dashboarding. So Grafana is a good example. Like in Grafana, you create your own custom dashboard. You wouldn't use console for that, right? Yeah.
Okay. Do you have a mic?
Yep.
Okay, perfect.
Do you have a recommendation for a doc or a blog post for after we've answered all of these quests for our specific use case, applying that to multi-account or to landing zone?
Yes. So you have to look for, I'll give you the keywords, AWS multi-account environment. And if you do that, the first three, last time I checked was today before the presentation. The first three is going to be the documentation, there's going to be a blog post, and there's going to be a perspective guidance on that. So if you look up the best, my recommendation is to go to the documentation, because it's built on in a tree structure. So you start with a landing page and they show you like the things that you have to do. You click and this opens another documentation for you. So it spans out, right? And if you go to all the branches, you end up understanding how to do it. And also the second thing is that I really recommend, but it takes time, is going through a well-architected framework tool. So there is actually a tool that asks you questions about your business and your requirements, and at the end spits out the report and tells you what to do. It's not perfect, because it cannot be. It's really good. There is a lot of questions, by the way, so brace yourself. It's like, tens of hundreds of questions that it'll ask you. And it also can take up the lens, like the perspective. So you can say, I'm an IoT business, so I want this to build from IoT lens. It's really called lenses, right? So this too, well-architected multi-account environment and well-architected framework tool. Yeah.
Thanks. Any questions?
We have a minute.
All right. And why you want whiteboard?
I wanted it to answer the questions, but you brought it at the end of the
It's
presentation.
the questions, buddy. It's your questions time. I didn't expect that outcome. Okay. Oh, perfect. But I just want to slide point something. Look how we brand it.
Wow. Yeah, but it should be over here.
Yeah, so come on. Don't.
Thank you. If you mentioned multi-account environment, where to use single account, where to use multi-account environment? Are there any?
So my go-to answer is accounts are free. You don't pay for an account, right? So if there is a real reason and you can actually vocalize that and tell me what's the reason for having a single account, go for it. But if you don't have a hard reason to do it, go for multi-account, always. That's what I would say.
Maybe how would you split?
So the question from the gentleman previously gets you to the documentation that gives you a very good example of how to divide your accounts on day zero, but also a good resource is Control Tower documentation. So if you go to AWS Control Tower, it creates a Bootstrap a good infra for you, so you can see what Control Tower creates and just copy paste or use Control Tower.
Yeah, Stack Overflow approach. I wait for that. Perfect. Any questions? All right. Perfect.
Because you mentioned Grafana, and I was wondering if there is no Grafana in my region, and I would like to create some dashboards, etc. So I need to transfer the data to the other region. So I can have
not necessarily. So you can either have the data somewhere else in the other region, but that's not recommended. You can have your own Grafana self-managed, right? I cannot tell you that there's going to be a Grafana in every region because this is not my responsibility. But what I've seen so far is three things. First, if you need it today, I would recommend having self-managed Grafana based on EC2 or maybe Kubernetes cluster if you really need this microservices. Now, the second is look at the roadmap, because roadmap might tell you that in 6 months Grafana will come to the region. And third one, you can look up a different solution than Grafana. That's the third one, right?
Okay, and maybe about the cost, but transfer between the regions is the same that like transfer outside the AWS, or that's the difference?
No, it depends what you use. So for example, with Cloud One, you don't pay for inter-region traffic.
Okay.
So if you have a Cloud One, the inter-region data is built into cost of Cloud One, which actually makes sense. And this is a recommendation for Cloud One. This is a use case for Cloud One. So if you're a multi-region and there is a lot of east-west traffic that's going to be happening in your environment, then use Cloud One, and then it's almost for free, actually for free, right? You pay for attachments and you pay for the Cloud One, but transferring data is for free.
But if there isn't?
But if there isn't, you can come up with, like, there is two approaches. Like, you break out from AWS. So if you have your backbone infrastructure, so for example, you're a corporate or an enterprise, you send data back, then you transfer it through your backbone and put data up, right? And then you have to calculate cost for yourself because I don't know how much you pay for this infrastructure. The second is to use AWS Backbone. You can use it in different ways. So for example, you can use it with ingestion through private link, right? So you can actually extend some private links and then just send it cross region through either like a VPN or maybe VPC peering or maybe transit gateway peering and calculate the cost for that. If that's not much, you will not pay too much because Grafana doesn't consume too much data, right? It's not that data heavy. It's not terabytes of data. It's not even gigabytes of data, isn't it? Like it's not too much, right?
Yeah.
I hope so. So you can do this as well, but then be careful and calculate costs before you do it, because cross-region is tricky.
Any more questions?
No questions. Then everybody waits for giveaways. All right.
No, we've got one. We've got one.
We got one. Perfect.
Okay. Hi everyone. So that's actually not the question, but my experience. So all items mentioned here are really very valuable, but they was not like taking into account on my project. So I joined it about half of a year, but project actually running for 3 years. And we have everything mentioned here. And the main, I think, issue was that account, one of accounts been created for test and dev. And there was mixed everything together. So developers have access, cloud engineers had access, like managers have access, and almost everyone have admin access. So finally, yeah, we have issue with outdated Terraform scripts that's very painful to fix. And last month we did clean up of account, mainly for garbage, and we saved 2,000 per month just doing that activity. Yeah,
that makes sense. So how we call this? It's a Phoenix approach.
Yeah, but it's really painful manual work. You need to find owner of resources.
Yeah, that's complicated. So usually when there is multiple actors, that's complicated. And I thank you for saying that, because that now it makes sense what I said.
Yeah, but
right?
if all that points will be would be taken into account at the beginning of the project, I think that can be eliminated most of problems. Yeah.
Yeah, I agree. Thank you.
Yeah, it's a consultant paradise, what you said right now. Do you have any other questions? Wojciech, thank you.
Thank you.
Thank you very much. Okay, come on. Ooh. Perfect. Always pleasure, CIA boss.
Do you want me to keep it?
Yeah, we just another one, because this quiz, I think we finished, right? So we have the answers already. But first, but not least, we will start from the most active people.
Yeah, I think
you
you've got the idea.
You choose. I'm just, humble servant. I will carry.
So for sure, the person in our first.
Yeah, first liner. Always. Woo! Just PM myself. Please. Backpack full of goodies. All right. Another one. You pick up.
So, no. Second one is for you.
Second one is for me. Woo! Perfect. What is it like? I like the open source idea. I love the open source idea, buddy. So this is for you. Open source idea. I really like it. And I really think that this makes amazing sense. And the third one is for you. So you pick it up. Who was the most active here? Who was the most active?
There are two people with two questions, so I'm not sure which.
All right, so we will give the blouse for the second one. First, get a backpack.
Okay, so.
Hey, dude.
I think the.
Hey, buddy. Stop watching OnlyFans. I saw you. I have WAF with SSL decryption in here. So I know what you're watching. Thank you very much. Thank you very much for questions. And the last but not least, the blouse and the cat from Deep Racer.
Yeah, so how to describe it?
I don't know. You can show with a finger.
Okay.
Come on, like a baby.
The person, the third person for me.
The third person. No, you need to show.
Maybe let's change.
All right, man.
Just give me the mic without the cable.
Mic without the cable?
Yeah.
And you feel like strained, right?
A little bit. Wait. Oh.
Okay, the cable mics.
So I will
I
go with
just
it.
took it, but maybe the size, you can change the size,
Okay.
no problem.
So here is the award.
All right. M, just right now it's going to be awkward if you will say something else, so you can come later on, don't worry. We can switch over that. And this was the giveaways that we get from our beloved sponsor and partner for many years, PMI. And now the list of winners, and some of them probably they're online, so we don't think that they will be here, so no worries. But who is here? Just give me a shout and I have blouse for you.
So the first $50 credit goes to Jan Sopata 10.
Perfect, buddy. You get a hat.
Yep.
What size? S, right?
This one is the blouse. This one is medium. Medium.
L or medium? You have medium.
Yeah.
All right, another one. As person Jesse.
Oh.
A person, sorry. A person, Jesse.
All right, and
Mm-hmm.
no, you need to come. Otherwise, you don't pick it up. Okay. You need to be visible on camera, you know. XL, L, A6, X6, XL. Maybe it's just take those for yourself and share with the others.
Who's next?
Next one, Malek Maciej.
Oh, perfect. We have L or XL. Now you need, now it's coming out. So, socks and a half.
Next one, Dominik Skowron 117.
So let's go.
You will feel like you belong, right? Here's the half for you, sir. Go ahead.
Max MJ W, sorry.
So come.
Come on, you get everything. So for you, it's L or it's XL? You have a half. All right, we will give somebody else. Don't worry. There's always somebody who wants to.
It's not me, like always.
It's not you at all.
Next one.
Yeah.
Yep.
All right. Rozum Alex.
Which one? Now you choose.
I don't know what is there.
Blouse, socks, and hat.
I'm seeing some similarities in the winners.
Okay, the last one, it's double XL. So you can sleep with your partner without any additional.
Coffees Radios. All free.
He will get a voucher. Next one.
Yeah?
Yeah, next one.
Okay. Disen.
You will get. That's perfect. Now you okay. Oh, don't worry.
You know, just a little of gym and thing.
All right, and at the end, oh my God, it's such a macaroni. Okay, so at the end, we want to thank you guys for coming here. We will have one more this year, right? I think that November somewhere, or did it 6 December, yeah, 6 December. We will do it after the event, so I hope it's going to be something funny to tell about. More or less, I hope you had a good time. We can still stay here as usual, grab some drinks and have a chat behind the scenes. So don't worry. Unfortunately, we need to say goodbye to our friends from the void. But thank you, everybody. It was a blast today. Thanks.